Hello my dear students, welcome to chemistry classes. Today I am going to start with the nitrogen family's chemical properties. Nitrogen family nothing but group 15, nitrogen, phosphorus, arsenic, antimony and bismuth. These are the nitrogen family members, their respective chemical properties. In that chemical properties, valency and covalency and oxidation states and reactivity towards hydrogen, reactivity towards halogen, reactivity towards oxygen and reactivity towards metals and anomalous properties and anomalous behavior and reasons. Okay, let us start with the one by one nitrogen family's chemical properties. So first one, chemical properties of group 15 elements. In that first one, valency. So student, you already know that nitrogen family, it contains 3 valency. It contains valency 3. Nitrogen family, it always contain nitrogen has valency 3. Okay, and covalency of nitrogen family, or you can say covalency of nitrogen. Covalency of nitrogen is 4. Okay, covalency of nitrogen is 4 due to 2s 1 orbital and 2p's 3 orbital. Okay, in the nitrogen 2s 1 orbital is present and 2p's 3 orbital is present. That is why nitrogen it shows the covalency, that is 4. Okay, apart from that, phosphorus, arsenic, bismuth, it shows the covalency more than 4. Okay students, nitrogen covalency is 4 and valency is 3. And next one, chemical property, oxidation states. This is important concept. Oxidation states of nitrogen family. Oxidation states of nitrogen family. Student, here nitrogen family, nitrogen, phosphorus, arsenic, antimony and bismuth, they shows or they exhibit oxidation states like -3, +3 and +5 oxidation states. Here nitrogen family exhibits nitrogen family exhibits -3, +3 and +5 oxidation states. -3, +3 and +5 oxidation states. Student, here in that there are 3 more important points are there regarding oxidation states of a nitrogen family. Here -3 oxidation state, -3 oxidation state decreases down the group. Student, here -3 oxidation state decreases down the group. Because nitrogen, phosphorus, arsenic and antimony and last one is bismuth. Okay, when you move along the group, means top to bottom, -3 oxidation state is decreases down the group because due to increase in size. When you move down the group, size becomes increases. Nitrogen to bismuth, size becomes increases, and as well as increase in the metallic character. So these are the main important reasons. -3 oxidation state decreases down the group. And second point should be here, that is +5 oxidation state. +5 oxidation state, it is also decreases. +5 oxidation state decreases down the group. So student, here also +5 oxidation state is decreases down the group. Okay, due to high ionization energy and increasing the size due to high ionization energy. Due to high ionization enthalpy or a high ionization energy, +5 oxidation state is decreases down the group. Okay, and one more important point, that is +3 oxidation state. +3 oxidation state, +3 oxidation state increases. +3 oxidation state increases down the group. Increases down the group. Student, +3 oxidation state is increases down the group due to inert pair effect. Here students, this last point is very important. +3 oxidation state increases down the group from nitrogen to bismuth. +3 oxidation state is increases. +3 oxidation state is increases due to inert pair effect. Due to inert pair effect. This is a very important point. Okay. Let us check. First one, oxidation state. Oxidation state of a nitrogen family. They exhibit +3, -3, and a +5 oxidation state. Here, -3 and +5 oxidation state decreases down the group, and a +3 oxidation state increases down the group due to inert pair effect. Okay, take it. First one, oxidation state. And next one, chemical property, reactivity towards hydrogen. Nitrogen families. Reactivity towards hydrogen. Reactivity towards hydrogen means here nitrogen family members, nitrogen, phosphorus, arsenic, antimony, bismuth, when they react with the hydrogen, they form a hydrides. Reactivity towards hydrogen. Here students, group 15 elements reacts with hydrogen. Group 15 elements reacts with hydrogen to form hydrides. Student, here group 15 elements react with the hydrogen to form hydrides of the type EH3. Of the type EH3. Here student, EH3 nothing but it may be NH3. Here N E means group 15 elements. Okay, NH3 and PH3 and ASH3 and SBH3 and last one BiH3. Okay, ammonia, phosphine, arsine, stibine and bismuthine. Okay, group 15 elements react with the hydrogen to form hydrides of the type EH3. Here E nothing but group 15 elements. Example NH3, PH3, ASH3, SBH3 and BiH3. Here these hydrides, they show some important properties. They are, first one I will write here, NH3, PH3, ASH3, SBH3 and last one BiH3. First point regarding the hydrides. Group 15 hydrides. First one, bond length. Bond length of NH3, PH3, ASH3, SBH3 and BiH3. Bond length increases down the group. This is important point, students. Bond length increases down the group. Means when you move along ammonia to bismuthine, its bond length becomes increases. And second one, bond dissociation energy. bond dissociation energy. Bond dissociation energy. Bond dissociation energy decreases down the group. Decreases down the group. Decreases down the group. Yes, students, bond dissociation energy decreases down the group. Okay, this is the second point. Next, third one. Reducing character or reducing property. Reducing property. Reducing property increases down the group. Increases down the group. Yes, students. Reducing property increases down the group. And next one, basicity. Basicity from NH3 to BiH3 decreases down the group. Decreases down the group. Decreases down the group. And stability also decreases. So these are the reactivity towards hydrogen. When group 50 element react with the nitrogen family, they form a hydrides of the type EH3. Example NH3, PH3, ASH3, SPH3 and a BiH3. Here these hydrides, they show some important properties. They are, first one, bond length increases when you move down the group, and a bond dissociation energy decreases down the group, nothing but from this group, and reducing property increases down the group, and basicity also decreases down the group. Means towards here, one bond length increases, dissociation decreases, reducing property increases, basicity decreases, decreases like this. Okay, so these are the some important property regarding reactivity towards hydrogen. Next one, students, reactivity towards oxygen. Reactivity towards oxygen. Reactivity towards oxygen. Means nitrogen family, when they react with oxygen, what it gives the product. Okay, let us first one. Nitrogen family, nothing but group 15. Nitrogen family, they react with oxygen, they forms oxides. They forms oxides of the type E2O3 and E2O5. E2O3 and E2O5. These are the two oxides they were produced during the reaction of nitrogen and oxygen. Okay, students, I will write the definition. Nitrogen family or group 15 family, group 15 reacts with oxygen. Group 15 reacts with oxygen to form oxides. To form oxides of the type E2O3 and E2O5. E2O3 and E2O5. Group 15 react with oxygen to form oxides of the type E2O3 and E2O5. So first here is the oxide which is higher oxidation state. The oxide which contain higher oxidation state. The oxide which contain higher oxidation state means it means which is acidic in nature. Means student here, oxide nothing but E2O3 or E2O5. Okay, E2O3 or E2O5. Those which contain higher oxidation state, they are acidic in nature. So here E2O3 or E2O5. Okay, whether it is E2O3 or whether it is a E2O5. Here E nothing but a group of 15 elements. Group 15 element. It may be nitrogen, phosphorus, arsenic, antimony, or bismuth. Okay. Next one, acidic character decreases down the group. Acidic character means oxide acidic character. E2O3 or E2O5. Acidic character decreases down the group. Acidic character decreases down the group. Acidic character decreases down the group. Okay. And next one, student, here, have it right here. E2O3 oxides of E2O3 oxides of nitrogen and phosphorus. These two are acidic in nature. These two are acidic in nature. Student, here E keyword nitrogen or phosphorus. E2O3 oxides of nitrogen and phosphorus are acidic in nature, and E2O3 oxide of E2O3 oxides of arsenic and antimony. E2O3 oxides of arsenic and antimony are amphoteric in nature. Amphoteric in nature. And last one, E2O3 oxides of bismuth. E2O3 oxide of bismuth. It is basic in nature. It is basic in nature. Students, this is the regarding about group 15 elements reactivity towards oxygen. When they react with oxygen, they form oxides in the form of E2O3 or in the form of E2O5. Here, the oxide which contain higher oxidation state will be acidic in nature. Here, acidic character decreases down the group, and E2O3 oxide of nitrogen, phosphorus are acidic in nature. E2O3 oxide of arsenic and antimony are amphoteric. E2O3 oxide of bismuth are basic in nature. Okay. And students, reactivity towards halogens. Reactivity towards halogens. Reactivity towards halogens. Here, students, nitrogen family members, when they react with halogens, they forms. When they react with halogens, they forms their respective halides. They forms halides of the type that is EX3 and EX5. Okay, student. Nitrogen family, when they react with halogens, they form halides of the type EX3 and EX5. Means trihalide and pentahalide. Here, pentahalides are more covalent. Here, pentahalides are more covalent than trihalides. Here, pentahalides are more covalent than the trihalides, because pentahalides, they have a higher oxidation state and they have a more polarizing power. Pentahalides have high polarizing power because pentahalides, they contain +5 oxidation state. +5 oxidation state elements have high polarizing power. And student, one more important point here, that is nitrogen does not forms pentahalides. Nitrogen does not forms pentahalides because non-availability of d orbital. Due to non-availability of d orbitals. Here, one important question is arise. Nitrogen NCl3 is known, but NCl5 is not known. Why? Because due to non-availability or absence of d orbitals in nitrogen. Okay, students. So this is about reactivity towards hydrogen. And one more, reactivity towards metals. Here I write reactivity towards metal. reactivity towards metals. Reactivity towards metals. Here, group 15 elements, when they react with the metals, they form, group 15 elements reacts with metal, they forms binary compounds. Binary compounds. Binary compounds of -3 oxidation state. Binary compound of -3 oxidation states. Students, reactivity with the metal. When group 15 element react with the metal to form a binary compound, those all binary compounds they contain -3 oxidation state. Okay, this is about chemical property of a group 15 elements.